I'm Bruce Segee. I'm the Henry R. and Grace V. Butler Professor of Electrical and Computer Engineering here at the University of Maine. And this is a video about a project course, ECE 498, that happened in the spring semester of 2011.
I'm Craig Verrill. I'm a student at the University of Maine. I helped work on the keyboard and USB functions.
I'm Tim Brim, and I also helped work on the keyboard USB functions.
I'm Forrest Flagg. I worked on the AV conversions.
I'm Jason Monk, and I worked on managing everything, so I played a little hand in everything.
My name is Andy Sheaf. I'm working towards continuing education credit for my professional engineering license, and I worked on the USB code.
My name is Tyler Lean. I worked on the PCB design and the schematic for this project.
So the motivation for this project is we wanted something that would be widely used even by people who aren't technically savvy. We wanted to have a device that plugs into a USB port but doesn't require any special software or any special hardware, any special operating system. The form factor that we decided on was a keyboard. That is, when it plugs in, the user's computer is convinced that the user has just plugged in a USB keyboard that is supported by Windows, Linux, Mac OS X, and any other operating system that you'd care to come up with. The data gathering then becomes essentially a series of keystrokes. You plug this thing in when you have a spreadsheet, for example, or a text document open, it types in the data, and then when you unplug it, you're able to process the data.
So this is the device here, and here's a quarter for scale. On the device, we have an integrated USB port where it can plug right into the computer. We have the AVR microcontroller, a programming header, and the temperature sensor.
The UMain device emulates a USB HID keyboard based on Atmel USB framework code. Data is collected and then output as keyboard presses and releases. Tabs and returns are inserted between values for use with a spreadsheet.
In order to output text as a USB keyboard, we redirected standard out to use a custom USB put character routine, which takes the ASCII code from the character you wish to print, converts it to keyboard scan code, and outputs it that way. That way we can use printf as it is in C without having any other headaches.
The USB put character routine outputs each character via USB as both a key press and release. The data output is voltage as an ADC value, followed by the temperature in degrees Celsius and Fahrenheit.
Right. So as mentioned previously, we're measuring temperature, and to do that we're using an MCP 9700, and that's just a little 3-pin package which takes a power supply. In our case it takes 5 volts, and it produces some analog voltage between 0.5 volts and 1 volt, which is dependent on the temperature. As the temperature goes up, the voltage goes up. So on our chip we somehow had to take that voltage and turn it into a number we could use. The AVR that we're using doesn't have any analog to digital converters, so we actually had to make do. We had an analog comparator, which will basically take 2 values and tell you whether one is bigger than the other. Our solution to doing analog to digital conversion uses an RC circuit. Anyone who's had experience with RC circuits knows that they produce a nice little exponential like this as they charge. They're approaching their battery voltage that you're charging them to. So we decided that if we've got the sensor at some constant voltage, we could figure out what voltage that was using an RC circuit. And the way we do that is we start charging a capacitor at time 0, and we start timing that. And then we wait for the 2 voltages to switch places, basically where they pass. We do that using the analog comparator I mentioned, and we time the difference between those. Now, using that time and the shape of this curve, we can figure out exactly what voltage the sensor is at and use some math from the data sheet of the MCP 9700 to turn that into a temperature.
Okay, so I want to give a quick demo of the device in operation. This is the board right here. I've set up at a computer. I've launched a Google spreadsheet, which is an online spreadsheet. Just clicked into column A1. What I'm going to do is I'm going to plug this in. I'm going to immediately start getting keystrokes from it. It's going to send samples every 2 seconds. I've got a hot butane soldering iron in my hand. I'm going to heat the temperature up, temperature sensor up to about 100 degrees or so, and then watch it cool down and plot the results. In it goes. Hot exhaust port. $107, $114. That's probably good. Hand this off camera to somebody who knows how to handle hot objects. And the temperature has stopped going up and started going down. Okay, and that's probably done what it's going to do. So it's cooled down more or less to room temperature. I'm going to remove it so that it stops sending me data. And then in the spreadsheet, what we've got, get rid of that, get rid of that, get rid of that, get rid of that, get rid of that. All right. Gives actual voltage reading, gives the temperature in degrees C, gives temperature in degrees F. What I'm going to do is I'm going to get just the numeric portion of the degrees Fahrenheit equal SPLIT. Using the split function, I'm going to split cell C2 on the capital F, and then when I fill this down, about like that, it will give me the numeric values. I'll put a nice nice heading at the top, select the column, insert chart, and taking all the default values, I will click OK. This is me heating it up. This is the heat actually percolating through the case into the sensor, and this is the sensor cooling off in a nice exponential decay back down toward room temperature.
Some advanced features on the premium umeter models include a rechargeable battery, which will recharge every time you plug it into your USB port, and flash memory. These two things will enable the user to capture sensor data values remotely without needing to be plugged into the computer.
We've also included functionality for up to 3 additional sensors for a total of 4, as well as RS-232 to USB conversion to allow the user to connect more advanced sensors such as GPS or accelerometers.
The last thing I wanted to do was put in a plug for Google Code. We did our entire project on a Subversion repository hosted by Google. They offered these services for free at code.google.com. If you want to see our project or any of the source code related to our project, you can go to this website here. If you can't read it here, you can look below, and there's a link in the details section of this video.